So today I'm going to talk about something that's been very exciting for us at littleBits and very exciting for me on a personal level, which is democratization of technology in general and looking at the Internet of Things in particular. Any minute now. Let's see if I could do this. Clearly, make technical problems. Hi. Oh, okay, but it's not moving.
I think you might just have to do this by hand.
No problem.
Just do last one. Okay. So go ahead and talk.
Hello. Okay, that's good. Democratization of technology. Can't even make a PowerPoint work. Okay. Anyway. Oh, still. Sorry, guys. 1 minute. Excuse me. No, it's not working. Well, I'll give you, the clicker doesn't, neither works. I'll give you a little bit of the background anyway before we look at the slides. So the Internet of Things, as many of you may have heard over the past, what feels like months, but really a little closer to a year, suddenly became this huge buzzword that every single small company, big company, advertisers have started to really put attention to. And the idea, for those of you that don't know, of the Internet of Things is this concept that our objects, our everyday consumer electronics will become connected to the Internet, so that your fridge, that one of the favorite examples, your fridge can tweet at you when you're out of milk. Or your garage door will send you an email if it remains open. Or that you're able to set your thermostat on through your phone. So all these promises that the Internet of Things comes with, that your life will become easier because your technology becomes smart and your devices in your home become smart. The problem, I believe, and we believe at littleBits, with the way the Internet of Things is currently playing out, is that it's a lot of the same way many other technologies have played out. If you look at the TV industry, for instance, TV started with all this promise of all the new information and the excitement that's going to come into your home with the TV industry. And suddenly, before we know it, now, when I look at going to buy a television, I can't tell the difference between a 3D and a 4D and a 4K, and I have no idea what all these different technologies mean. Some of the biggest innovations are coming from large companies in their R&D departments, coming up with new ideas, giving them obscure names, and then parachuting them onto us. And we, the consumer, no longer understand the difference between the product and, most importantly, what they mean to us. And the Internet of Things, the way it's been playing out, has really had, I would say, two very polarized ideologies. One ideology is more of a utility. So companies like Apple, which is now coming up with their own HomeKit devices, or Google, or even Cisco or GE, are coming up with utility-type solutions for the Internet of Things, where it means just like you would subscribe to an electricity grid, you would subscribe to, for example, the GE Home, and they would come with a utility, a top-down approach that you have to buy into entirely and have all your devices connected to. It's a very archaic model. We know that there are lots of problems with the way the power grid has been set up over decades. Then on the other side of the spectrum, you have a lot of companies coming up with very prescribed devices that have very prescribed behaviors to solve certain problems in your home. Turn your light on with your phone, or get your garage door to talk to your fridge, to talk to your car, to respond to your SMS on your phone. These sort of obscure prescribed behaviors that somehow have an appeal, but they're very defined, and they may not define the richness of our lives and the richness of how we live in our homes. And so we find that these two extremes are very problematic, and there's a really important middle for us to create our own Internet of Things, for us as everyday people, whether we're technology savvy or not, to be able to create the solutions that really will make the Internet work for us at home, and what that means. So what I'm going to take you through is a few things that we've done at littleBits in an attempt to do that. But really, this is very much at the beginning. So it's anybody's game on to what's going to happen. But we think that the biggest opportunities are going to be what you do with it for yourself. Excellent. All right. So these are some of the devices that I've been mentioning before. You know, thermostats, scales, light bulbs that are connected to the internet. Each of them comes with a promise of what they're going to do and how they're going to help you. One of the really interesting quotes that I've recently read as I was preparing for this talk is by Howard Rheingold. Really kind of starting to think about, criticize what the Internet of Things is going to. We will live in a world where many things won't work and nobody will know how to fix them. And it's a bleak view, but unfortunately, I think this already happened. I think it's already happened. So many of the devices around us operate kind of on their own, and we don't understand how they work, and nobody knows how to fix them. And sort of case in point, the TV industry that I was mentioning. You know, now if your TV breaks, I'm willing to bet a bunch of money that very few people know how to fix a TV, and few people know how to buy a TV even. And so that's already happened. And so we have the opportunity with the Internet of Things not to play this out in the same way. We have the opportunity to really take control of this technology that genuinely has a lot of promise to make our lives, our society, and our economy better, but we have to do it right this time. So if we look at sort of zooming out a little bit and looking at technology trends in general, some of the technologies that have transformed societies the most have usually started in the hands of experts, but then someone or something or institution came along, democratized them, and made them accessible to everyone, and that's where the real innovation started. Printing has gone through that. Game development has gone through that. It used to be that only Nintendo or Sony can make the best games. And now suddenly anyone with a couple of weeks can create the most popular game on everybody's phone or everybody's devices. Software development in general went through that. It used to be that software in general was a very functional piece of technology. Only very sort of functionally focused engineers could create software. And only when software was made accessible and the tools to create software became accessible to everyone, have we really seen a lot of art come out of software, a lot of really interesting companies come out of it, and really sort of turned that industry on its head. Manufacturing is the same thing. I don't need to tell this crowd that 3D printing has brought a lot of changes to the manufacturing industry. It used to be that only GE can manufacture something. Now you can buy a $3,000 3D printer at home and run a small manufacturing facility from your home. It's not going to compete with GE, but at least we are sort of taking control and really starting to innovate. But what about hardware? What about hardware? How are we going to really make that medium accessible so that we can see really innovations happen in that space? The way we look at it a little bit is that really democratizing hardware comes in 4 different pieces. Lowering the barrier to understanding, lowering the barrier to iterating, making it universal, and then most importantly, raising the ceiling of complexity. If you lower the barrier to understanding, you start to address that first problem that we talked about in the TV industry, where people at least understand what the device is, what the products are, and what hardware really means. That's crucial. You can't do anything before you lower the barrier to understanding. Lowering the barrier to iterating means that people can start to participate and iterate, and through small improvements, really start to reach big innovations. Making it universal means that it's not something that is only confined in the hands of engineers or confined in the hands of experts that have had PhDs. It means making it universal so that people can start to cross-pollinate disciplines. Some people that are artists that think about hardware can come up with new ideas to make hardware. People that are software developers that now have access to hardware can start to infuse with new ideas as well. And this discipline cross-pollination only comes if you've made it universal. And finally, and most importantly, raising the ceiling of complexity. Nobody is interested, and certainly not us at littleBits, nobody is interested in creating an easy bake oven type of technology. In order for it to be a contender in the world, it has to be real technology, and so it has to allow for complexity. But starting with a low barrier to understanding and ramping up to complexity is the best way to do that. So the way we've approached this, sort of taking all these principles together, we've set out to make hardware modular. So littleBits, for those of you that don't know, is a library of modular electronics. Each circuit is a single module that is fully engineered and pre-assembled, and they range from the very simple, like a button, a light sensor, to the very complex, like wireless radio frequency or cloud connection, or programmable. So every one of these circuits are a building block, and they snap together with magnets in billions and trillions of different combinations, and you start really small, but you can build up really complex things with it. So the way we look at it is that if you have the sort of raw one-off circuit board on one side that you've created on a breadboard, and you have to usually be an engineer to do that or follow instructions very closely, and you have a finished product on the other end where a company has created this product with prescribed behavior and parachuted it onto you, we really live in the middle. We've tried to create this module that becomes a building block for you to be able to have functionality that is embedded so that you're not reinventing the wheel every time like we have on the left side, but at the same time have enough open-endedness so that you can create meaningful things. And really the reason we do this is our mission is to put the power of electronics in the hands of everyone. Let me show this little video. So the idea is by making these electronic circuits modular, you're able to start very small. In the beginning of the video, we saw a pressure sensor with a set of LEDs that you're just very simply increasing or decreasing the amount of current going through by the pressure sensor. And you start building up to creating a wirelessly controlled robot, to creating a wirelessly a bathroom sign, so you know if somebody is in the bathroom or not. And if you wanted to add programming, then you can really start to create these complex software-hardware interactions that you otherwise wouldn't have been able to. And so what we really like to sort of provide is this ability to create all these different combinations without added complexity, but really raising the ceiling so that you can make things that are more complex if you wanted. So that if instead of doing what's on the left side, which is creating a wireless transmitter-receiver pair, and it takes you many days, it takes you hundreds of dollars to do, and they're very prone to error, start with the building block, have a wireless transmitter and receiver right away so that you can be creative. Now that you've had that, now you can say, what do I want this wireless transmitter and receiver to do? That's what matters. It's what the thing does. It's not how you got to the thing, except in the learning environment, obviously. So really the ultimate thing that we see is that rapid prototyping of plastics, that the way it's been happening in 3D printing, it's brought a lot of really exciting learning and prototyping applications. We want to see rapid prototyping in electronics in the same way. So going back to the Internet of Things, well, how is that relevant? Hardware obviously is a big component of the Internet of Things, so is software. But in order to really achieve democratization of the Internet of Things, what we have set out to do is make the Internet a modular block. So the Internet, something that is abstract, that feels outside of us, that feels like it's sort of somewhere on the cloud, in the web, how does it break out of the screens, and how does it become a building block that you can really use it to create hardware that is innovative, that is powerful, that is creative, and that is cross-disciplinary? So if we look at it, and this is sort of what has been guiding us, taking a building block, a very traditional old school building block like cement brick. During close to that time, we've had Legos to play with, to prototype with, to really understand what that brick meant. But then when the transistor came along, how do you really make a transistor, that new building block of society, how do you make that into a building block that is usable? And we look at it as this modular block that we have next to the last one, like a motion trigger. But the next frontier is how to make the internet into a block like that and make it really as simple, as instantaneous, and as empowering as it could be. So here's another little video to show you. Oops.
The Internet of Things is getting so full of things. Instead of buying all the new things, let's reinvent what we already have. This is the cloud bit. It can make any dumb thing an internet-connected smart device. You can talk directly to your things and not be crazy. Because now, it'll talk back. So whether you're recreating the most popular things, bringing your home to life, inventing the incredible, or prototyping the next billion-dollar idea, the cloud bit is the easiest way for anyone to snap the internet to anything.
So what happens when you take the internet out of its abstract form and make a building block out of it? What is possible? First, you can reinvent the most popular Internet of Things devices. You can create your own Nest, your own Sonos. You can connect your own window AC and not have to throw it out and buy a new internet-connected AC. Your old AC is perfectly functional. There's no reason why you can't snap the internet to it. You can create your own next big idea. So things that you've never thought were possible, things that maybe you're not going to necessarily go start a company, learn engineering for 4 years, and try to go into production. But maybe you have an idea. Like one of our community members suggested once, an SMS doorbell. A doorbell where when you push the button, instead of it only ringing, it sends you a text message so that if you are in your garage or if you are wearing headphones, you're able to get a message that somebody's at the door. That person may not have necessarily wanted to start a company with that idea. And in fact, some people do. They go to Kickstarter and they raise money for it. But to prototype this next big idea is still a hurdle for people. And so maybe that's where the new innovations are going to come from. And finally, and the last sentence is cut off, what I believe is the biggest promise of the Internet of Things: solve a problem with an audience of one. Something that maybe no other company is going to make for you. Something that is so specific to how you live, so specific to how your home is set up, and so specific to how you like to sort of enjoy life, that it may not be a big enough market for a company to come and make a product and a whole category for. So one example, which I'll show in a minute, is one of our community members has a farm, and he has 2 daughters, and every day his daughters fight over who's going to feed the chicken. And they're always fighting, and he can't tell whether the chicken have been fed or not. And so he has to go out into the chicken coop and lift the bag of chicken feed and find out whether or not the chicken have been fed, depending on the weight of the bag. And we met him once at a conference at Solid earlier this year, and he was joking around and he was saying, oh yeah, all this fancy technology, like that's what I actually need. And so we brainstormed with him literally for a few minutes, and the next thing we knew, he created this is it up in the upper right corner? He created this chicken feed monitoring system using the cloud bit, and is able to remotely, while he's at home or other places, figure out whether the chicken have been fed and sort of act accordingly. So this is, I don't know if this exists, but I feel fairly confident that there are no people sitting in in a boardroom or in an R&D studio trying to figure out the chicken feed market and how to solve a problem for that audience. But just because it's a problem with an audience of one does not mean that it's any less worth whatever the order of these words solving, because this is what supposedly the Internet of Things comes with a promise of. And so this is something that we consider very empowering. Other examples you see here are the SMS doorbell on the upper left corner. In the middle, it's a gumball machine that spits out gumballs when a certain hashtag is mentioned on Twitter. And below that, below the SMS doorbell, you see a DIY controlled thermostat. So this is the idea that if you have a thermostat at home, or even further, if you don't, we don't have it here, but if you have a window AC unit that's in your home, you don't have to throw that out to go buy a Nest. You don't have to toss out things that are perfectly functional just because you want to bring them to the 21st century. So this is a retrofit of a thermostat so that you can, with your phone, set the temperature and it will mechanically adjust the thermostat. Below that is a weather dashboard. That's just a beautiful design project that one of our designers did at littleBits to sort of visualize the weather without you having to go to your phone or to a computer every morning. And in the bottom right, actually, is a project by Jude. Hi. Jack and Jude actually together. Sorry?
Cadbury the bunny.
Oh, Cadbury the bunny, exactly. So tell us about what the Cadbury the bunny is doing.
Well, when she wants kale, she begs on her little beg bar. So she pushes on a lever switch, which turns on the phone and sends me a text or an email that, I gotta get some kale. So
Why not? Why not? That's the point. The point is that every person should be able to utilize technology in the way they want and make the internet work for us in the way that we want. And if it's to train a bunny to order kale, or if it's to have gumballs spit out at random hours of the day, or if it's something so functional, which is just controlling your AC with your phone, none of it should be off limits. We have some of these projects on display if you'd like to come see us. Not all of them, but this is a snapshot of our booth here at Maker Faire. You can see some of these projects in action. As you can tell, we like purple. It's not hidden from anyone. But you can see some of these in action and get inspired for what you can make. But then I go back to sort of, in closing, to talk about what is really the next step of democratizing technology. Creating the building block is a piece of it, and that helps sort of lower the lower the barrier to understanding, lower the barrier to iterating, making it universal. That's all sort of one part of it. But how do you really raise the ceiling of complexity, and how do you really make it open-ended and really make it powerful and empowering? If we look back at some of these industries, many of them have gone through several different iterations of this democratization so that they become genuinely life-changing. So our look at it is, okay, what is now, after the building block, what is the next big problem to solve to truly make hardware and the Internet of Things in particular democratized? Earlier this week, we launched this initiative called the BitLab. And the BitLab is a marketplace for user-generated hardware, or the way we like to call it, it's the App Store for hardware. So what it means is that you can submit your module. So the library right now is 60 modules. It has infinite possibilities, but it's still limited. It's only 60 modules. If you wanted a humidity sensor, it is now not available. So to truly democratize hardware and to truly allow every person to create what they want, we have to also let the building blocks be in the hands of people. So the way it works is that you submit your idea for a module, let's say a humidity sensor. You can gather votes. So if you gather up to 1,000 votes, it'll be considered for production, depending on production feasibility and its design. And then littleBits will manufacture it and will give you, manufacture it and will shoulder all the financial investment for it. And then we will sell it and distribute it and give you 10%. And the idea is that some of these best ideas are locked in people's brains and locked on sketchbooks, and people are not necessarily prepared to go into production. With software, it's easy. You get a laptop, you take a one-week class to learn HTML, and you're up and running. In hardware, it's more difficult. You need financial backing, you need to purchase equipment, and to go into production, it's a whole new set of skills and set of relationships. So we sort of take over that and give the inventor 10% so that we can see some of these more richer ideas come up, and we've seen so many really interesting ones. So the way we look at it, and the reason we call it the App Store for hardware, is really it is kind of the closest model that we can compare to, where the iPhone, if you look at it, is the platform. That's what we consider the library. The API is the BitSnap, which is the magnetic connector that we've made and now is available. The HDK, and the way for you to get started, is this hardware development kit that you can get started really quickly and create your own modules. The app is, in this case, the bit. It's the module, and all of these different bits become more powerful as they're added to each other. And finally, the App Store is technically the BitLab. So sort of really trying to learn from the best things that software has done, and the software industry has done, and the music industry has done, and some of the best technologies that have really disrupted fields, and really trying to learn the best of it, and really trying to see what makes sense and adapt it to our needs. So we've had a few celebrity developers that we've worked with that we've already gone into production with. So Jay Silver, I think everybody knows it in this crowd. Jay is a phenomenal inventor, came out of MIT from the Media Lab, created a board that allows you to connect everyday objects as a sensor. So bananas, oranges, a bucket of water, and really be able to play the piano or play Mario Brothers with fruit. And so he was one of the developers we worked with. Bear Conductive is another. They make conductive ink and these beautiful applications for wall displays and for proximity sensors that have been really functional. Arduino is a module that we've worked with the Arduino team, and that's Massimo Banzi here as part of their Arduino at Heart program to create an Arduino bit with somewhat reduced functionality, and Korg is another one, the music technology company with whom we created the synth kit. But some of the others are now up, and we're working with a few. We've started working with a few to sort of get the mechanics up and running, but now it's open to the public. So Backyard Brains are creating EMG sensors. The founder is a neuroscientist, and he's very interested in getting more kids interested in studying the brain. And so he's set out to make neuroscience fun and set out to make neuroscience engaging. And so he's created this EMG bit so that you can really play and create instruments and create lessons out of studying your muscle activity. The Bleep drum is a drum beat that's been made by Bleep Labs to augment music, and the oscilloscope by Gabotronics is more functional, so you can see what's inside your circuit. So I'm going to show you just one of the. Oops. Let me see if I can do. I'm not sure I'm on the internet, but I'll try. Nope. Anyway, so we have them. You can see them live in our booth, where you can see and play with them in action. It's actually really engaging to start to imagine how a sensor, an EMG sensor that's really made for medical purposes, you think about combining it with the internet, a building block, and now suddenly you've created your own monitoring system for your own health. So you can create highly functional things, and you can iterate on them. Are you going to go into production with 20,000 of these and sell them? No. But this is the way that you're going to innovate, that you're going to iterate, that you're going to think of combinations that otherwise weren't possible. So in closing, what I like to say is we believe that the next billion-dollar idea isn't going to come from Apple, isn't going to come from Google. It's going to come from designers and artists and parents and people in their homes that are really finding a sticky situation that either only they have or that they identify for everybody else. And that's where the true innovations are going to come from. There's a reason something like Oculus VR started as a Kickstarter campaign and became a billion-dollar company. There's a reason some of these ideas are coming out of people that are not necessarily trained, and they're really changing the way the world has been. And so it's just about really putting more fuel to the fire. So the only thing that I would say is the hardware developer community, unlike the software developer community, has been considered somewhat secondary for the past couple of decades. People have tended to put software developers on a pedestal and consider them sort of the big minds of our society. And we believe a lot of that is actually in the minds of hardware developers and makers. And so we just want to support them. So whether you want to submit your module, whether you want to cast your vote and support somebody else's, or whether you just want to dream and put your dreams out there, we really invite you to participate and really try to fuel this hardware revolution. Thank you.